The given numerical is: a magnet swap resistance is connected in series with a moving coil ammeter consisting of a milliammeter and a suitable shunt in order to. It is asked in GATE 2003, and here are the options. So in this question it is given that the moving coil ammeter. What do you mean by moving coil? Moving coil is nothing but the permanent magnet moving coil, that is the PMMC instrument. And now that PMMC instrument is used as an ammeter here. So what is happening in this PMMC used as an ammeter? Let us see in short before seeing all the options or the correct option. Now for that, consider this network. If suppose only PMMC used as an ammeter to measure some value of current, in that case the circuit is like that. Here only one voltage source will be there, one ammeter will be there in series with the load. It will directly measure now the current, but the value or the range of that measurement of current is very low. Let us suppose that is the 50 microamperes only. And now if we want to increase that range, now if we want to measure the 60 microamperes of current, in that case we have to connect one shunt resistance in parallel with this ammeter. So here one shunt resistance is connected, that is nothing but the RSH. When we are connecting this shunt resistance, the extra amount of current will now pass through this shunt resistance, and only 50 microamperes will pass through that meter and it will not cause any damage to that meter. So this is the purpose of this shunt resistance. Here you can see that there will be the two resistances in the network, that is first meter resistance and second that is the shunt resistance. This meter resistance is made up of copper and this shunt resistance is made up of manganese. As these two resistances are made up of different materials, that means their temperature coefficients will also be the different. In this case, when the current will pass through this complete network, there will be some temperature rise will occur. Now that temperature rise will changes or will cause the value of resistance to change, because the temperature coefficient of these two resistances will be different because they are made up of different materials. Due to this temperature effect, the division of the current will now get changes or will get disturbed. Now as the division of current will get disturbed, this meter will show some error. If suppose we want to measure 10 microamperes of current, due to this temperature rise and the materials of these two resistances are different, due to that the error will occur and now that meter will read, suppose that is the 9 microamperes of the current. So to avoid all these errors or these temperature effect, what we have to connect? We have to connect one resistance in series with the ammeter, which is made up of same material as that of the shunt resistances. So here we are connecting one resistance in series with the ammeter, that is nothing but the swamping resistance denoted by RSW, which is connected in parallel with the shunt, you can say it. This swamping resistance is now made up of the material that is the manganese, and here the shunt resistance is also made up of manganese. The value of this swamping resistance is 20 to 30 times greater than this meter resistance. So in this series network where the meter resistance is there and the swamping resistance is there, here the swamping resistance will act as the dominating resistance. So we can neglect the effect of temperature rise of this meter resistance. Now you can see in this complete parallel branch, this swamping resistance is made up of manganese and this shunt resistance is also made up of manganese. Now their temperature coefficients will now get same. So the temperature effect or the errors which is caused due to the temperature effect will now get reduced by connecting this swamping resistance, which is act as the dominating resistance in the series branch where meter resistance and swamping resistance is connected, and it is made up of manganese as that of the shunt resistance. So due to all these conditions, what is happening? The errors will get reduced. That means the temperature effect of the complete network will get reduced. So by connecting this swamping resistance, we can change or minimize the temperature variation. Now go on the options. You can see all the options. The correct option is, that is option number A, because it minimizes the effect of temperature variations by connecting a swamping resistance which is made up of manganese. The correct option is now option number A.